Have you ever wondered what it would be like to witness the single moment that changed everything on Earth? To see, with your own eyes, the instant when one world ended and another began? Can you imagine standing beneath a sky that suddenly becomes brighter than the sun itself, feeling the ground beneath your feet tremble with the power of 10 billion atomic bombs, yet experiencing it all with the gentle reverence of deep time? What would it feel like to follow a visitor from the depths of space on its 165 million year journey to our planet? To drift alongside a mountain-sized wanderer as it crosses the vast darkness between worlds, carrying within its ancient rock the power to reshape continents and redirect the course of life itself. Tonight, we journey to that pivotal moment 66 million years ago, when the sky fell to earth, when fire rained from heaven, and when the giants who had ruled our planet for 160 million years gracefully stepped aside to make room for the world we know today. Have you ever held a piece of clay from the boundary layer? That thin, dark line found in rocks around the world, and realized you were touching the very dust of that cosmic visitor? That you held in your hands the crystallized memory of the day everything changed? If journeys through deep time bring you the same wonder they bring me, if you find peace in these ancient memories, please consider liking and subscribing to follow along for more. And if someone you care about might appreciate drifting through Earth's memories as they drift off to sleep, why not share this gift of wonder with them? I'd love to know where in the world you're listening from tonight, and what time you're settling in for this journey. Leave a comment below and let me know what corner of our modern Earth you call home. And if there are other moments in deep time you'd like to explore together, other ancient memories you'd like me to share, tell me in the comments. Your suggestions guide our future travels. But for now, let's leave the modern world behind. Settle in now. Let the weight of your day become a distant memory. Breathe in the quiet of your room, and with your exhale, let the present moment gently drift away. We are not bound by clocks or calendars tonight. Together, we will step outside of time, to a place I remember well, a world waiting in the deep past. I am the Chrononaut, and I have drifted through the ages like smoke through still air. Tonight, I invite you to join me on a journey, not forward, not back, but deeper into the memory of Earth itself. Close your eyes if you haven't already. Feel yourself becoming lighter, untethered from this moment, ready to slip between the seconds and find yourself in a time before time was counted. Come with me now. Let us cross the threshold together. Tonight, I take you to witness what may be the most profound single moment in Earth's recent memory. Not to a gradual change spanning millions of years, but to a day, an hour, a heartbeat, when everything that had been became everything that would be. I remember it with the clarity that only comes from having been there, suspended in that moment like a consciousness preserved in amber. We drift now across the boundary between present and past, between the familiar and the ancient. Feel the years peeling away like layers of sediment. 66 million years dissolving beneath us like morning mist. The world we approach knew no humans, no grass, no flowers as we understand them. It was the realm of giants, the kingdom of scales and feathers, a planet ruled by creatures so magnificent that their very bones still inspire wonder in museum halls across our modern world. But on this day, this one singular day, the universe had prepared a visitor, a wanderer from the deepest cold of space, carrying within its ancient stone the power to close one of Earth's greatest chapters and begin writing another. Come closer now. Feel the threshold thinning. Soon we will stand in that ancient light, breathe that primordial air, and witness together the gentle transformation that some call catastrophe, but which I have learned to see as the universe's way of making room for new dreams. I remember drifting in the silence between worlds, in that perfect darkness where only starlight writes its ancient messages across the void. Here, in this cosmic cathedral of emptiness, our visitor had been traveling for longer than most mountain ranges have existed. 165 million years it had wandered, a piece of the asteroid belt flung loose by some long-forgotten gravitational dance, carrying within its 6-mile width the concentrated memory of the solar system's birth. I can still feel the profound silence that surrounded this cosmic messenger. No sound travels in the vacuum between worlds, yet there was something musical about its journey. The way it caught starlight on its tumbling surfaces, the way solar wind carved gentle patterns in its ancient rock. For all those millions of years, it had been falling toward this moment, toward this appointment with a blue-green world that hung like a jewel in the cosmic dark. As I drift alongside our visitor, I can sense its composition, not just rock and metal, but time itself compressed into mineral form. Chondrules older than Earth's oceans catch the distant light of the sun, each tiny sphere a fossil from the solar system's youth. This wanderer carries within it the memory of the disk from which all planets formed, a library written in stone and metal about beginnings that predate all life. Now I turn my awareness toward Earth, toward the world that waited below like a sleeping child, unaware that this would be its last day of innocence. What a magnificent sight it was, so different from the Earth you know. The continents themselves were strangers, North America and Europe still drifting toward their eventual embrace, India racing across the ancient Tethys Sea toward its destiny with Asia. The climate was warm, almost tropical even at the poles, with no ice caps to crown the planet's ends. I can see vast, shallow seas, where the great plains now stretch their golden waves. These were the Western Interior Seaway, warm waters that split North America into eastern and western islands, teeming with marine reptiles whose very names would become legends. Mosasaurs cutting through the water with reptilian grace, plesiosaurs moving their paddle limbs like underwater birds in flight. But it is the land that captures my deepest attention, for this is the realm of the giants. Forests of sequoias and ferns stretch across continents, their canopies alive with the rustle of creatures that have ruled this world for 160 million years. I can sense them now, these magnificent beings. A Tyrannosaurus matriarch moving through dappled forest light, her amber eyes scanning for the movement that might mean a meal. Her footsteps, each one capable of leaving a track 3 feet long, press into earth that has never known the tread of human feet. In a clearing not far away, a family of triceratops grazes peacefully, their massive frilled heads lowered to crop the ferns and cycads that carpet the forest floor. The adults weigh as much as modern elephants, but they move with surprising gentleness, their horned faces designed more for display than destruction. Nearby, their young ones play in ways that would remind you of modern children, if you could see past the bony frills and 3 horned faces to the curiosity and joy that animates all young things. Above the canopy, a formation of pteranodons rides the thermal currents, their 25-foot wingspans casting moving shadows on the forest floor below. They are not birds, though they rule the air with avian grace. They are something older, something that found the secret of flight millions of years before the first true bird would spread its feathered wings. By a lake that reflects clouds unchanged from those you might see today, a herd of sauropods moves like living mountains. Brachiosaurus and Apatosaurus, their necks rising 40 feet into the air, browse among treetops as casually as modern giraffes take leaves from acacia branches. When they call to each other, their voices carry across miles, low-frequency sounds that travel through the ground itself, felt as much as heard by every creature in the forest. The air itself is different, thicker, richer with oxygen and water vapor, perfumed with the scent of flowering magnolias and early roses. Yes, roses, for this is when flowers first began their conquest of the world, adding color and fragrance to a planet that had known only the green of ferns and conifers for hundreds of millions of years. Bees, still new to their partnership with blooming plants, move from flower to flower, writing the first chapters of pollination's ancient dance. And in the warm, shallow seas that lap against shores of pure white limestone, coral reefs build their calcium carbonate cities, just as they do today. Ammonites spiral through the water like living nautilus shells, their tentacles reaching for prey, their eyes as intelligent as any octopus. Rudis, giant clam-like creatures, filter the warm water, building massive reefs that rival any modern coral formation. But I must turn my attention now to one particular place, one specific stretch of coastline, where shallow tropical seas meet the low-lying limestone plains of what will one day be called the Yucatan Peninsula. Here, where the water is perhaps 300 feet deep at its greatest, where fish dart between coral heads and marine reptiles cruise like underwater leopards, the universe has prepared a stage for the most dramatic entrance in Earth's recent memory. The water is crystal clear, the kind of blue-green transparency you might find in a modern Caribbean lagoon. Schools of primitive fish move through the water in silver clouds, their scales catching the filtered sunlight and throwing it back in patterns that have danced unchanged for hundreds of millions of years. On the sea floor, layers of limestone and sediment tell the story of millions of years of gradual deposition, each stratum a page in Earth's patient autobiography. Above this peaceful scene, the sky is the kind of perfect blue that makes your heart ache with its beauty. Cumulus clouds drift like white islands in an azure sea, their shadows racing across the water's surface, bringing brief moments of coolness to the warm tropical day. The sun, slightly dimmer than the one you know but somehow more golden, bathes everything in light that seems to make colors more vivid, edges more defined. Nothing in this perfect scene suggests that in mere hours, this exact location will become the center of the most transformative event in 66 million years. The fish continue their eternal dance. The coral polyps extend their tiny arms to capture plankton. The sea itself breathes in its ancient rhythm of tide and current. But now I turn my awareness skyward, beyond the blue dome of atmosphere, beyond the scattered clouds, to where our cosmic visitor has finally begun to feel the gentle pull of Earth's gravity. After 165 million years of wandering, it has found its destination. The appointment, scheduled by physics and probability before life itself had ventured onto land, is about to be kept. I drift now with our ancient wanderer as it begins its final approach, feeling the first whisper touch of Earth's gravitational field. For 165 million years, this 6-mile wide mountain of stone and metal has traveled through the cosmic dark, tumbling slowly end over end, its surface carved by micrometeorites and painted by the solar wind into patterns of impossible beauty. Now, for the first time in all those eons, it feels the pull of another world. At first, the change is subtle, a gentle nudging of its trajectory, a slight acceleration that builds momentum with each passing day. The asteroid, which I've come to think of as an ancient messenger rather than a destroyer, begins to bend its path toward the blue-green jewel that grows slowly larger in its field of vision. Its surface, scarred by billions of years of cosmic weathering, catches Earth's light and throws it back into space in brief, brilliant flashes that would look like a new star to any creature that might notice it. I can feel the deep, mineral patience within this visitor. Its rock formed in the first days of the solar system, when the disk of dust and debris around our young sun was still learning how to become planets. Within its crystalline structure lie chondrules, tiny spheres of olivine and pyroxene that condensed from the solar nebula itself, each one a fossil from the birth of worlds. This wanderer carries within it the very substance from which Earth was built, coming home after an exile measured in hundreds of millions of years. As we travel together through the darkness, I sense the gradual awakening of Earth's magnetosphere to our approach. The planet's magnetic field, generated by the liquid iron churning in its core, begins to interact with the small magnetic signature embedded in our visitor's metallic components. It is like two magnets sensing each other across a great distance, a recognition that speaks of common origins in the same stellar nursery. Days pass in this cosmic approach, each one bringing us closer to the moment of contact. I watch the Earth growing larger, its blue and white and brown beauty becoming more defined with each revolution. The continents become visible, their alien shapes reminding me how different this world is from the one you know. That great inland sea, splitting North America into two islands, catches the sunlight like a mirror, while the vast forests of the northern continents show as green brushstrokes against the brown of exposed land. Now I can see weather patterns developing, the spiral of storm systems that shows Earth's rotation, the river of clouds that marks the movement of air masses across continents that still remember the warmth of recent volcanic activity. This is a living world, breathing and circulating, maintaining the delicate balance that has allowed life to flourish for billions of years. In just hours, that balance will be tested in ways it has never been tested before. As we approach the edge of Earth's atmosphere, traveling now at 43,000 miles per hour, I sense the first molecules of air beginning to interact with our visitor's surface. At this speed, even individual atoms of hydrogen and helium become bullets of incredible energy, each collision contributing to a heat that will soon transform our ancient wanderer into something entirely new. The first sign of atmospheric entry is a gentle glow, barely visible, as the outermost layers of Earth's atmosphere begin to compress ahead of our messenger's bulk. The air, unable to get out of the way quickly enough, begins to heat and ionize, creating the first faint aurora of what will soon become a light brighter than the sun itself. This is the moment of no return, when our cosmic visitor ceases to be a citizen of interplanetary space and becomes, for the first and last time, a citizen of Earth. I can feel the sudden transition as we cross the boundary from vacuum into atmosphere. The silence that has surrounded our journey for 165 million years gives way to the first whispers of sound, the high-pitched scream of air being compressed to temperatures hotter than the surface of stars. The rock beneath us begins to glow, not with reflected sunlight, but with its own inner fire. As friction transforms the kinetic energy of our cosmic speed into heat beyond imagination. Now the transformation accelerates. The front surface of our visitor, which has faced the cosmic void for longer than dinosaurs have walked the Earth, begins to melt and vaporize. Droplets of liquid rock, heated to thousands of degrees, stream behind us like tears of molten stone, creating a tail of fire that stretches across hundreds of miles of sky. The sound grows from a whisper to a roar to something beyond sound, a vibration that travels through rock and water and air, announcing to every living thing on the planet that something unprecedented is about to happen. I watch the surface of our messenger peel away layer by layer, each atom of vaporized rock carrying with it the memory of the solar system's birth. These particles, heated to plasma, glow with colors that have no names, painting the sky in hues that no earthly sunset has ever matched. The heat is so intense that it ionizes the air itself, creating a tunnel of charged particles through which we travel like a bolt of living lightning. Below us, the first creatures begin to notice the new star that has appeared in their sky. A pteranodon, soaring on thermal currents high above the western interior seaway, tilts its crested head to follow this brilliant point of light that moves faster than any star should move. Its primitive brain cannot process what it sees, but some deeper instinct makes it call out, a sound that carries across the water to alert others of its kind. On the ground, a Triceratops family pauses in their feeding as the shadow of our passage flickers across the forest floor. The adults lift their massive heads, their small eyes tracking the brilliant streak that cuts across the blue dome of sky like a crack in the world itself. The young ones, curious as all children are, take a step toward this new wonder, their three-horned faces turned upward in what might almost be interpreted as awe. A Tyrannosaurus matriarch, the apex predator of her world, stops mid-stride as the light from our approach begins to outshine the sun itself. For the first time in her life, she encounters something that makes her feel small. Her amber eyes, adapted to spot movement at great distances, track our descent with an intelligence that has taken 66 million years of evolution to develop. She does not know that she is witnessing the end of her world, but some part of her recognizes that this moment is unlike any other in her experience. Now we are truly burning, our ancient rock transformed into something that exists only in this moment of transition between cosmic wanderer and earthly force. The heat generated by our passage creates its own weather system, spawning shock waves that race ahead of us, compressing the air into walls of superheated gas that glow like miniature suns. The very atmosphere parts before us like a curtain, revealing layers of sky that no earthly creature has ever seen. I can feel our visitor's mass changing as its outer layers vaporize and stream away. What began as a mountain-sized chunk of asteroid material is becoming something more elemental, more primal, a concentration of pure energy wrapped in a shrinking envelope of molten rock. Yet even as it burns away, its core remains intact, carrying within its crystalline heart the full momentum of our 165 million year journey. The sound of our passage has grown beyond the ability of any living ear to process. It is a continuous thunder that shakes leaves from trees hundreds of miles away, that sends birds spiraling in confusion from their nests, that causes the great sauropods to lift their long necks and trumpet calls of distress that will be answered by herds across entire continents. This is not just sound, but a physical force, a pressure wave that travels through solid rock as easily as through air. Now I can see our destination clearly. Below us, the shallow tropical seas of the Yucatan Peninsula spread out like a blue-green welcome mat, their coral reefs and limestone shallows unaware that they are about to become the epicenter of the most dramatic geological event in 66 million years. Schools of fish move in their eternal patterns. Ammonites spiral through the clear water. Marine reptiles cruise like underwater dragons through forests of kelp and coral. The water is perhaps 300 feet deep where we will make contact, warm and clear and teeming with life that has taken millions of years to evolve into the perfect balance we see below. Rudis reefs, built by giant clam-like creatures, create underwater cities that rival any modern coral formation. In the deeper channels, mosasaurs hunt with reptilian grace, their paddle-shaped limbs propelling them through the water like living torpedoes. Above the water, pteranodons wheel and cry, their voices carrying across the waves in calls that have remained unchanged for millions of years. They do not yet understand that the brilliant star growing brighter in their sky will soon transform their world beyond all recognition. For now, they simply exist in the eternal present that has been their kind's gift for longer than most mountain ranges have stood. Our visitor is beginning to fragment now, the incredible stresses of atmospheric entry causing fractures to race through rock that has remained solid for longer than complex life has existed on Earth. But these fragments do not scatter. They hold together in a loose formation, like a family staying close through a dangerous passage. Each piece glows with its own inner fire. Each one carries a portion of the total energy that will soon be released. The heat of our passage is so intense that it begins to affect the atmosphere itself. Water vapor in the air dissociates into hydrogen and oxygen, these elements recombining in violent chemical reactions that add their own light to our cosmic flame. Nitrogen and oxygen, compressed beyond their normal limits, begin to glow with colors that no earthly aurora has ever displayed. I can sense the precise moment when our visitor crosses from the upper atmosphere into the lower, denser layers of air that will provide the final resistance to our journey. The compression wave ahead of us becomes a wall of superheated plasma, a bubble of star-hot gas that vaporizes everything it touches. Birds caught in our path simply cease to exist, transform from living creatures into component atoms in the space of nanoseconds. Below us, the surface of the sea begins to respond to the heat radiating from our approach. Steam rises in columns that twist and spiral like waterspouts, but these are made not of wind but of water being boiled away by heat more intense than any volcano could produce. The first ripples begin to race outward from the point where we will make contact, concentric circles that move at the speed of sound through water, carrying the first whispered warning of what is about to unfold. Now we are in the final seconds of our journey. Our visitor, reduced to perhaps half its original size, but still carrying the momentum of eons, begins its last transformation. The remaining rock starts to behave more like a liquid than a solid, flowing and reshaping itself as it encounters air pressures that would crush any normal stone to powder. Yet it holds together, held by forces more fundamental than mere chemical bonds, held by the appointment that was made in the depths of space 165 million years ago. I can see individual creatures now in perfect detail. A school of ammonites, their spiral shells catching the light of our approach, continues its ancient dance through the warm waters. A mosasaur, 30 feet of reptilian grace, pauses in its hunting as shadows and light play across the sea floor in patterns that no living thing has ever witnessed. On a nearby beach, a family of small dinosaurs, perhaps early relatives of modern birds, pause in their feeding as the light from above begins to outshine the sun itself. The water below us is beginning to glow now, not with reflection, but with its own inner light, as the heat radiating from our passage raises the temperature of the sea itself. Steam explosions begin to occur, columns of superheated vapor that reach toward us like welcoming arms. The very air above the water starts to shimmer and dance, creating mirages that show multiple images of our approaching messenger. In these final moments, I find myself marveling at the precision of the universe. This exact spot, this precise angle, this specific velocity, all determined by gravitational interactions that began when the solar system was young. There is something almost musical about the mathematics of this moment, as if the universe itself has been composing a symphony for 165 million years, and this is the crescendo. Our visitor is now a shape of pure energy wrapped in a thin shell of vaporized rock. The heat it generates creates its own weather system, spawning tornadoes of superheated air that spiral away from us like the arms of a galaxy. Lightning begins to arc through the ionized gases in our wake, creating electromagnetic pulses that will circle the planet faster than our fragments will travel through the air. I can feel the sea floor now, 300 feet below the surface, its limestone layers recording millions of years of peaceful deposition. Each stratum tells a story of ancient creatures living and dying in these warm waters, their shells and bones settling slowly to the bottom to become the rock that forms the foundation of this place. In moments, these patient stones will experience pressures and temperatures that exist nowhere else on Earth's surface. The last thing I sense before contact is the profound silence that seems to fall over the world. Birds stop singing, the wind holds its breath. Even the waves seem to pause in their eternal rhythm. It is as if the planet itself recognizes the magnitude of what is about to occur, as if every living thing feels in its deepest being that this moment is unlike any other in the history of their world. Then, in an instant too brief for thought, too powerful for description, our cosmic visitor completes its 165 million year journey home. The moment of contact exists outside of normal time, in a space where nanoseconds stretch like hours, and the fundamental forces of the universe reveal their hidden strength. I am present at the exact instant when 6 miles of cosmic rock, traveling at 43,000 miles per hour, meets the limestone floor of an ancient tropical sea. The mathematics of this encounter are simple. Kinetic energy equals 1/2 mass times velocity squared. The reality is beyond all mathematics, beyond all imagination, beyond all earthly experience. In the first nanosecond, the front face of our visitor comes into contact with the seawater. The collision is so violent, the energy released so immense, that matter itself begins to behave in ways it normally does only in the hearts of stars. The water does not splash or boil. It simply ceases to exist as water, its molecular bonds shattered, its component atoms scattered into a plasma hotter than the surface of the sun. The limestone beneath the water fares no better. Rock that took millions of years to form from the patient accumulation of coral and shell fragments is vaporized in an instant so brief that light itself barely has time to cross the space involved. The calcium carbonate that once formed the homes of countless sea creatures becomes a cloud of ionized gas, expanding at velocities that challenge the speed of sound itself. But this is only the beginning. The bulk of our visitor continues downward, its mass and momentum carrying it through vaporized rock and water as if they were no more substantial than morning mist. The pressure of its passage compresses the Earth's crust to densities found only in the planet's deep interior, creating temperatures that exceed those in nuclear explosions by orders of magnitude. I follow this descent into the Earth itself, watching as our cosmic messenger buries itself in rock that has remained undisturbed since the planet's youth. Each foot of penetration releases energy equivalent to thousands of nuclear weapons. Each meter transforms solid stone into states of matter that have no names. The asteroid doesn't drill or dig. It simply continues to exist in the space where rock used to be. while that rock is transformed into expanding clouds of plasma that begin their own journey outward. The cavity that forms around our visitor grows with impossible speed. In the first second, it reaches a depth of over a mile, its walls lined not with solid rock, but with molten material heated to temperatures of 50,000 degrees. This is not the familiar red-orange glow of lava, but the blue-white incandescence of matter pushed beyond its normal limits, radiating energy across the entire electromagnetic spectrum. As our asteroid penetrates deeper, it encounters different layers of Earth's geological history. The relatively young limestone gives way to older rocks, each stratum telling the story of different ages in our planet's life. Shales that formed in ancient seas, sandstones that once were beaches, granites that crystallized from magma chambers deep beneath vanished mountain ranges. All are vaporized in the order of their formation, creating a reverse timeline of Earth's history, written in superheated gas. The pressure wave that radiates outward from this initial impact travels through solid rock at speeds that make sound seem motionless. This is not merely vibration, but a reorganization of matter itself, a shock front that transforms everything it touches. Rocks are compressed beyond their elastic limit, their crystal structures rearranged into forms that exist nowhere else on the Earth's surface. Quartz becomes coesite, then stishovite, forms of silicon dioxide that require pressures found only in the planet's deep interior. But even as our visitor buries itself deeper into the Earth, the energy it releases begins to work its way back toward the surface. The vaporized rock and water, compressed to unimaginable densities by the continuing impact, seeks release with a force that dwarfs any earthly explosion. This expanding cloud of plasma begins its race back toward the surface, carrying with it the signature of our cosmic messenger and the taste of the Earth's deep interior. The crater continues to grow, its walls moving outward at speeds that challenge the transmission of sound through rock. In the first few seconds, the cavity reaches a diameter of several miles, its depth approaching the point where our visitor's momentum is finally absorbed by the sheer mass of displaced planet. The walls of this growing void are lined with rock that has been melted, vaporized, and shocked into crystalline forms that will puzzle geologists for millions of years to come. Now begins the rebound, one of the most spectacular phenomena in all of geology. The Earth's crust, compressed beyond its limits by the impact, begins to spring back like a vast rubber sheet. Rock that was pushed downward with unimaginable force now races back toward the surface, carrying with it the memory of pressures and temperatures that exist nowhere else on the planet's surface. This rebound creates a central peak that rises miles into the air, a mountain formed in seconds from the very substance of our visitor and the rocks it encountered. The energy release continues to climb. What began as the kinetic energy of a 6-mile asteroid has become something far more vast, the equivalent of 10 billion atomic bombs detonating simultaneously. This energy seeks every possible avenue of release, creating phenomena that exist only in this moment, in this place, at the boundary between cosmic force and planetary resistance. The vaporized rock and water that was created in the first moments of impact now begins to flow back toward the surface. But this is no gentle emergence. This material, heated to temperatures that exist only in stellar cores, explodes outward with a violence that defies description. It carries with it not just heat, but pressure, not just energy, but the very substance of our cosmic visitor, now intimately mixed with the limestone and water of the impact site. As this explosion of superheated material reaches the surface, it encounters the atmosphere of the Cretaceous world. The interaction is immediate and catastrophic. Air molecules, compressed beyond all normal limits, begin to glow with their own inner light. The boundary between ocean and atmosphere, between liquid and gas, ceases to have meaning as everything within miles of the impact site is transformed into a single expanding bubble of plasma. The sound of this emergence is beyond description. It is not merely the loudest sound ever heard on Earth, but something that transcends sound itself. The compression waves travel outward at supersonic speeds, carrying with them not just vibration, but physical force capable of leveling mountains. Trees hundreds of miles away will feel this pressure wave, their ancient trunks snapping like twigs before wind that moves faster than hurricanes and carries the heat of stars. But the most spectacular aspect of this moment is the birth of the ejector curtain. The vaporized and molten rock, propelled by pressures that exist nowhere else on Earth's surface, begins to fountain upward and outward in a display that makes every earthly geyser seem like a gentle spring. This material, a mixture of our cosmic visitor and the limestone it encountered, rises not in a single column, but in an expanding dome of fire that grows to encompass the entire horizon. I followed this ejector as it climbs through the atmosphere, watching as droplets of molten rock the size of boulders race toward the edge of space. Some of this material, the finest particles vaporized to plasma in the first moments of impact, will reach velocities sufficient to escape Earth's gravity entirely. These atoms, forged in the heart of an asteroid and liberated by cosmic collision, will join their parent body's former companions in interplanetary space, carrying the signature of this moment to worlds that circle distant stars. The larger fragments follow ballistic trajectories that arc high above the planet's surface before beginning their return journey. As they climb, they cool and solidify, transforming from droplets of liquid rock into glass spherules that catch the light like emerald and amber jewels. These tektites, as they will one day be called, carry within their crystalline structure the memory of temperatures and pressures that no earthly process could create. The crater itself continues to evolve, its shape changing with each passing second, as the forces unleashed by the impact work themselves out through the Earth's crust. The initial cavity, carved out in the first moments of contact, begins to collapse under its own weight, creating a series of concentric rings that will mark this site for millions of years to come. Each ring tells part of the story. The central peak where our visitor came to rest, the inner ring where the first rebound occurred, the outer rings where the shock waves finally spent their force. The heat generated by this impact begins to affect everything within hundreds of miles. The air itself, superheated by radiation from the expanding fireball, begins to glow with its own light. This thermal pulse travels outward at the speed of light, reaching creatures hundreds of miles away in the instant of impact. Forests begin to smolder, then burst into flame as the radiant energy washes over them like an invisible tide of fire. In the shallow seas surrounding the impact site, the water itself begins to boil. Not the gentle bubbling of a pot on a stove, but the violent transformation of liquid into steam that occurs when water encounters temperatures of thousands of degrees. Vast clouds of superheated vapor rise from the ocean's surface, creating their own weather systems, spawning tornadoes of steam that reach toward the stratosphere. The marine life in these waters experiences a transformation that is both violent and strangely gentle. The ammonites spiraling through the coral gardens, the mosasaurs hunting in the deeper channels, the rudis filtering the warm water through their giant shells, all are touched by heat so intense that molecular bonds simply dissolve, returning these complex creatures to their component atoms in timeframes measured in milliseconds. Yet there is something almost peaceful about this transformation. These creatures do not suffer, do not experience pain as we understand it. The change occurs too quickly for nervous systems to register, too completely for any awareness of transition. In one instant, they are living beings, complex arrangements of carbon and calcium and water. In the next, they are part of the expanding cloud of superheated gas that carries the signature of our cosmic visitor outward into the world. The limestone sea floor, built up over millions of years from the patient accumulation of coral and shell, experiences its own transformation. The calcium carbonate that once formed the protective homes of countless creatures is broken down into its component elements, creating clouds of calcium oxide and carbon dioxide that will have their own roles to play in the global changes to come. This is the limestone's own form of resurrection, a return to the elemental state from which it first emerged in the ancient seas of Earth's youth. As the minutes pass, the full scale of the impact crater becomes apparent. The cavity, now approaching its final diameter of 93 miles, represents one of the largest impact structures in Earth's recent history. Its depth, measured from the peak of the central mountain to the rim of the outer ring, spans 12 miles of vertical relief, carved out in the space of an hour. This is geography created by appointment, topography written by the marriage of cosmic force and planetary resistance. The rock that lines this crater tells a story that will fascinate geologists for millennia to come. Here is stone that has experienced pressures equivalent to those found hundreds of miles below the Earth's surface. Here are minerals that form only under conditions of extreme shock, crystals that exist nowhere else on the planet. The impact has created its own geological epoch, compressed into the space of hours rather than spread across millions of years. But perhaps the most remarkable aspect of this moment is the silence that follows. After the tremendous release of energy, after the roar that circled the planet multiple times, after the crash and thunder of a 6-mile mountain falling from the sky, there comes a moment of profound quiet. It is not the absence of sound, but something deeper, the silence that follows when the universe has spoken in its loudest voice and now pauses to let the echoes settle. In this silence, I can feel the planet itself adjusting to what has just occurred. The Earth's crust, fractured and displaced by forces beyond normal experience, begins the long process of settling into its new configuration. Deep beneath the surface, magma chambers that were disturbed by the impact begin to find new pathways toward the surface. The very rotation of the planet has been affected, its spin altered by the addition of our visitor's mass and momentum to its own. Yet even as I observe these changes, I can sense the seeds of creation. The energy released by the impact has not simply vanished, but has been transformed, converted into heat and motion and chemical change that will drive new processes, create new possibilities, open new chapters in Earth's continuing story. The crater itself will become a nursery for new forms of life, its shocked rocks providing mineral environments that exist nowhere else on the planet. The vaporized remains of our cosmic visitor, now intimately mixed with the rock and water of the impact site, begin their own journey around the world. These atoms, forged in the heart of the solar system and delivered to Earth after a journey of 165 million years, will become part of new rocks, new waters, new living things. The asteroid has not been destroyed but transformed, its substance distributed into the very fabric of the planet it came to visit. As I drift above this scene of cosmic sculpture, I am struck by the profound beauty of what has just occurred. Yes, there has been violence, energy release on a scale that defies comprehension. But there has also been a kind of marriage, a joining of cosmic wanderer and planetary home that will enrich both participants. The Earth has received a gift from the depths of space, a contribution of elements and energy that will shape its future in ways both subtle and profound. The impact is complete, but its effects are just beginning to unfold. The energy that was released in this moment will travel outward in waves of heat and pressure, carrying change to every corner of the planet. What began as the appointment between a cosmic messenger and an ancient sea will become the defining moment of an entire geological age. The energy released at the moment of impact does not remain confined to the crater that gave it birth. Like ripples spreading from a stone dropped in still water, but traveling at velocities that make sound seem motionless, waves of force begin to radiate outward through every medium the planet offers, through solid rock, through water, through the atmosphere itself. I follow the first of these waves as it races through the Earth's crust at speeds approaching 4 miles per second. This is not merely vibration, but a reorganization of matter itself, a compression wave that transforms everything it encounters. The limestone and sandstone layers that form the Gulf Coast begin to ripple like water, their solid structure temporarily liquefied by the passage of energies normally found only in the planet's deep interior. In forests hundreds of miles from the impact site, trees that have stood for centuries feel the ground beneath them buck and heave as seismic waves arrive with the force of freight trains. Ancient sequoias, their trunks broad enough to drive carriages through, sway like saplings in a wind that travels through rock rather than air. Some crack and fall, their massive forms crashing to Earth in the first casualties of what will become a planetary transformation. But it is the atmospheric effects that create the most spectacular display. The column of vaporized rock and water that fountained up from the impact site has now reached heights where the air becomes thin, where the blue sky fades to the black of space itself. Here, 60 miles above the Earth's surface, the ejecta begins to spread outward in an expanding dome of glowing particles that catches and reflects sunlight like a second dawn. I drift among these particles, marveling at their variety and beauty. Here are droplets of limestone, heated to liquid in the first moments of impact, and now cooling as they arc through the thin air of the upper atmosphere. They form perfect spheres as they travel, surface tension shaping them into glass beads that range in color from deep green to amber to crystalline clear. These tektites, as future scientists will name them, are among the most beautiful creations of cosmic violence, jewels forged in the marriage of asteroid and planet. Larger fragments follow higher trajectories, some reaching altitudes where they can see the curvature of the Earth itself. From this vantage point, they begin their ballistic return journey, following paths calculated by gravity and momentum to deliver them to locations hundreds, even thousands of miles from their point of origin. As they fall, they heat the air around them to incandescence, creating artificial meteors that streak across the sky like falling stars, each one carrying within its molten heart a piece of the cosmic visitor that started this cascade. The finest particles, vaporized to plasma in the initial explosion, are carried even higher. Some reach velocities sufficient to achieve orbital altitude, where they begin to circle the planet like a temporary ring system. From space, Earth would appear to wear a crown of glowing debris, a halo of stone and metal that catches sunlight and throws it back in glittering displays that outshine any aurora. But the most significant particles are those that reach the very edge of space before beginning their return. These have been accelerated to velocities approaching escape velocity, and as they fall back toward Earth, they compress the air ahead of them into shock waves that glow with their own inner fire. The atmosphere, unprepared for this invasion from above, begins to heat under the accumulated impact of millions of returning fragments. I can feel the moment when the first of these particles begin to re-enter the lower atmosphere. They arrive not as individual droplets, but as a continuous rain of molten stone and glass, each fragment contributing its own heat to the growing conflagration. The air itself begins to glow, not with the reflection of firelight, but with its own incandescence, heated by the accumulated energy of countless tiny impacts. The phenomenon spreads outward from the impact site in a great circle, like a wave of fire moving across the planet's surface. In the forests of North America, leaves begin to smolder as the thermal pulse reaches them. The radiant heat, traveling at the speed of light, arrives long before the sound of the impact, long before the seismic waves, long before any other evidence of what has occurred in the distant Gulf of Mexico. A family of triceratops, grazing peacefully in a forest clearing, feels the first touch of this invisible fire. The adults lift their massive heads, their frilled faces turning toward a sky that has begun to glow with an unnatural light. They do not understand what they are seeing, but their experience tells them that the quality of light has changed, that something fundamental has shifted in their familiar world. The heat continues to build. Ferns and cycads that have carpeted forest floors for millions of years begin to curl and brown at their edges. Flowers, those recent additions to Earth's palette, close their petals against the growing warmth. In the canopy above, pteranodons call to each other in voices that carry confusion and growing alarm. Their keen eyes, adapted to spot fish from great heights, can see the strange glow beginning to appear on the northern horizon. But the thermal pulse is only the beginning. Now the first of the larger fragments begin to return, their ballistic trajectories carrying them to destinations determined by the mathematics of the impact. A chunk of shocked limestone the size of a building begins its final approach over what will one day be Texas, heating the air around it to temperatures that vaporize everything within its path. The sound of its passage is unlike anything ever heard on Earth. Not the whistle of wind, but the roar of air being torn apart and rebuilt, molecule by molecule, by the passage of matter moving at cosmic velocities. Birds take flight in panic, their primitive brains unable to process the source of this thunderous noise that seems to come from the sky itself. When this fragment finally impacts, it strikes with the force of a nuclear weapon, creating its own secondary crater and sending up its own column of vaporized earth. This pattern repeats across the continent as hundreds, then thousands of similar fragments complete their journeys. Each impact adds its own contribution to the growing violence. Each explosion releases its own cloud of dust and debris into an atmosphere that is rapidly becoming unbreathable. In the shallow seas where the original impact occurred, different forces are at work. The tremendous energy released by the collision has not dissipated, but has transferred itself into the water, creating waves unlike any in Earth's history. These are not the familiar swells of wind-driven seas, but wall-like structures of pure liquid energy, rising 1,000 feet above the normal surface of the ocean. I follow one of these tsunamis as it races outward from the impact crater at speeds approaching that of sound itself. The wavefront, invisible from the surface but carrying the power to level mountains, moves through the warm waters of the Cretaceous seas, like a liquid mountain, traveling at the speed of an express train. When this wall of water encounters the shallow coastal plains of what will one day be the Gulf Coast. The result is immediate and complete. The sea simply rises, not with the gradual surge of a normal high tide, but with the sudden violence of water moving under pressure that defies all earthly comparison. Coastal forests that have stood for thousands of years are swept away in minutes, their massive trunks carried inland like splinters on the tide. But even more dramatic is what happens when these waves encounter deeper water. As the tsunami races into the Atlantic basin, it maintains its energy, its height, its tremendous momentum. The wave, now spread across hundreds of miles of ocean frontage, carries with it not just water, but the dissolved remains of the limestone sea floor, the vaporized substance of our cosmic visitor, the organic matter of countless creatures that were in the wrong place at the most significant moment in 66 million years. Marine reptiles, those magnificent predators that ruled the Cretaceous seas, find themselves caught in currents beyond their comprehension. A mosasaur, 30 feet of perfectly adapted aquatic hunter, is swept along by forces that make its powerful swimming seem futile. Yet there is no struggle, no desperate fight against the inevitable. The water that carries it is warm, familiar, simply moving in directions and at speeds that no current in its experience has ever matched. As the tsunami races across ocean basins, it begins to interact with the returning debris from the impact. The sky is now raining stone on a global scale, each fragment adding its own heat to water that is already beginning to steam from the accumulated thermal energy. The boundary between sea and air becomes unclear as superheated vapor rises from the surface in columns that tower into the stratosphere. On the continents, the combination of thermal radiation and returning debris creates conditions that exist nowhere in the modern world. The air temperature begins to rise not gradually, as in a normal hot day, but rapidly, approaching levels that make survival impossible for any creature adapted to Earth's normal climate. The oxygen itself begins to combust, creating spontaneous fires that need no fuel beyond the superheated atmosphere. A herd of hadrosaurs, those gentle duck-billed dinosaurs that have thrived in the warm wetlands of North America, feels the first effects of this atmospheric transformation. The air they breathe, which has sustained their kind for millions of years, begins to burn their lungs with each breath. They do not understand what is happening to their world, but their bodies tell them that the very substance of life has become hostile to their existence. Yet even in these extreme conditions, there is a strange beauty to what is occurring. The particles returning from their journey to the edge of space create light shows that surpass any earthly aurora. Streaks of green and gold and silver trace across the darkening sky as glass spherules heat to incandescence in their passage through increasingly dense air. Each trail is a signature of the original impact, a reminder that what began as a cosmic appointment has become a planetary transformation. The larger fragments create their own spectacular displays. A piece of shocked limestone the size of a mountain, following a trajectory that will take it halfway around the world, begins to break up in the atmosphere above what will one day be Europe. Each piece that separates creates its own fireball, its own thunder, its own contribution to the growing cacophony that is drowning out every natural sound on Earth. As these fragments impact, they create secondary craters across the landscape, each one a smaller version of the original cavity that gave birth to this global catastrophe. The accumulated effect is to pepper the entire planet with impact sites, turning Earth's surface into something resembling the face of the moon, scarred by cosmic violence, but bearing those scars with a dignity that speaks of forces too large for resistance. the atmospheric effects continue to intensify. The air, superheated by the accumulated energy of millions of returning fragments, begins to glow with its own inner fire. This is not the warm red of a sunset, but the brilliant white of matter pushed beyond its normal limits. Temperatures approach those found in the photosphere of stars, creating conditions that have never before existed on Earth's surface. In this environment, the chemistry of life itself begins to break down. Proteins denature, cell membranes dissolve. The complex molecular machinery that sustains all terrestrial creatures simply ceases to function. Yet this is not a violent death, but a gentle dissolution, a return to the elemental state that preceded the long journey from chemistry to biology. The plants are the first to show the effects. Leaves that have captured sunlight for millions of years begin to curl and blacken, not from fire, but from the simple inability of their cellular structure to maintain organization in temperatures that reduce water to vapor and carbon to gas. The great forests that have covered the continents since the Carboniferous begin to disappear, not consumed by flame but transformed into their component elements and released into an atmosphere that is itself becoming a chemical soup of unprecedented complexity. Above this transformation, the upper atmosphere tells its own story. The finest particles from the impact, those that reach the very edge of space, are now beginning their own return journey. But these have been changed by their brief exposure to the cosmic environment. Ionized by solar radiation, influenced by the Earth's magnetic field, they carry within their crystalline structure new chemical combinations that have never before existed on our planet's surface. As these particles begin to settle through the atmosphere, they seed the air with condensation nuclei that will affect weather patterns for centuries to come. Clouds begin to form at altitudes and in patterns that have no precedent in Earth's meteorological history. The very process of precipitation is altered as water vapor condenses around particles that carry the signature of cosmic collision. The sound of all this activity has grown beyond description. What began as the roar of a single impact has become a continuous thunder that circles the globe, an acoustic signature that can be heard on the opposite side of the planet from where our cosmic visitor made its appointment with destiny. The pressure waves, traveling through rock and water and air, create resonances that cause the entire planet to ring like a bell struck by a cosmic hammer. In the midst of this planetary symphony, individual creatures continue their own final movements. A pteranodon, caught in updrafts of superheated air, finds itself carried to altitudes where the air becomes too thin to support flight. Yet rather than falling, it seems to float, suspended in currents of hot gas that rise like invisible towers from the burning landscape below. A Tyrannosaurus, the apex predator of its age, stands motionless in a clearing where temperatures are rising beyond the tolerance of any earthly life. Its amber eyes, which have witnessed the triumph of predation for 20 years of successful hunting, now reflect light from a sky that glows brighter than any sun. There is no fear in those eyes, no comprehension of ending, only the vast patience that has characterized its species for millions of years. As the hours pass, the global effects begin to dominate local phenomena. The thermal pulse has now circled the planet, creating a belt of superheated air that girdles the Earth like an invisible equator of fire. The debris fallout continues, each fragment adding its own contribution to atmospheric conditions that are rapidly making the planet uninhabitable for any form of complex life. Yet in this apparent ending, I can sense the seeds of beginning, the energy being released, the elements being redistributed, the chemical processes being initiated. All of these will contribute to the conditions that will eventually allow new forms of life to emerge. The carbon being released from vaporized limestone will eventually become part of new atmospheric cycles. The shocked minerals being created in impact craters will provide new environments for chemical evolution. Even the heat that is making life impossible today will drive atmospheric processes that will eventually return the planet to habitability. The day that began with the arrival of a cosmic visitor is ending with the transformation of an entire world. But this is not a conclusion, but a transition. Not a death, but a metamorphosis. Not an ending, but a clearing of space for new stories to be written in the patient stone and restless atmosphere of our ever-changing planet. In a forest clearing where dawn light filters through leaves that have whispered in wind for 100 million years, a family of triceratops begins what will be their final day. Though they move through their morning routines with the same patient grace that has characterized their kind since the age of mountains was young, the matriarch, her massive head crowned with a bony frill that catches the early light like polished armor, lifts her three-horned face to taste the air with senses that have guided her through 25 years of successful survival. Something is different about this morning, though she cannot name what calls to the deep instincts that have kept her alive through drought and plenty, through the changing of seasons and the passing of decades. The air carries scents that speak of distant places, ionized particles that make her nostrils flare with curiosity rather than alarm. Above, the sky holds a clarity that makes colors more vivid, edges more defined, as if the very light has been purified by passage through conditions that exist nowhere in her earthly experience. Her mate, a bull whose horn scars tell stories of battles fought for the right to continue their genetic legacy, pauses in his feeding to follow her gaze. Together, they scan their territory with eyes that evolution has perfected for spotting movement at distance, for reading the subtle signs that mean the difference between safety and danger in a world where tyrannosaurs hunt with intelligence and patience that matches their own. Their offspring, 3 juveniles whose adult size is still more promise than reality, continue their play with the boundless energy that characterizes all young life. They chase their own shadows, mock charge at falling leaves, practice the head-lowering displays that will one day serve them in territorial disputes or courtship rituals. Their calls to each other carry across the clearing in voices that blend the deep rumble of their parents with the higher tones of creatures still growing into their full power. The forest around them pulses with life that has taken 66 million years to reach this moment of perfect complexity. Magnolia trees, among the first flowering plants to grace the earth with blooms of impossible beauty, release perfume that draws insects whose relationship with pollen has become one of nature's most successful partnerships. Bees, still newcomers in the grand scheme of terrestrial evolution, move from flower to flower in dances that will influence the genetic future of both insect and plant. In the canopy above, a family of small dinosaurs that will never be given scientific names moves through the branches with an agility that speaks of millions of years of arboreal adaptation. These creatures, no larger than modern house cats, but infinitely more colorful, feed on fruits and insects with tiny clawed hands that manipulate their world with precision that rivals any primate. Their calls weave through the morning air in complex songs that carry meaning beyond simple communication. Territorial claims, mating invitations, warnings of danger, expressions of joy in the simple fact of being alive in a world made for their success. Near a stream that meanders through the forest, like a silver thread stitching together different communities of life, a small herd of hadrosaurs lowers their duck-like bills to drink from water that reflects clouds unchanged from those that drift across your modern sky. These gentle giants, their hollow crests designed to produce calls that can carry across miles, communicate in voices that range from subsonic rumbles that travel through the ground itself to trumpet calls that announce their presence to every creature within hearing. The water they drink has circulated through this ecosystem for millions of years, carrying dissolved minerals from rocks that remember the birth of continents, organic compounds from forests that grew and died and returned to soil in cycles so vast that individual trees become mere notes in symphonies that play across geological time. Each droplet contains the history of weather systems that have watered this same ground since before the Atlantic Ocean reached its current width. But now, in this moment that seems like any other morning in the 165 million years that dinosaurs have owned the world, something unprecedented appears in their sky. At first, it is nothing more than a new star, a point of light where no star should be in the broad daylight hours when only sun and moon and planets show their faces to earthbound creatures. The Triceratops matriarch is the first to notice, her head turning northward toward a brightness that grows even as she watches. Her brain, smaller than your fist, but shaped by millions of years of successful survival, processes this information with the same careful attention she gives to every unusual sight or sound or scent that enters her awareness. This is new, her instincts tell her. This is unprecedented. This requires attention. Her mate follows her gaze and sees what she sees, the impossible star that moves across the dome of sky with purpose that no celestial object has ever shown. Together they stand motionless, their massive forms frozen in attitudes of alert attention, while around them the forest continues its eternal routines, unaware that the cosmic appointment made 165 million years ago is now only hours from completion. High above the forest, a formation of pteranodons feels the change before they see it. Their hollow bones, evolved for maximum lightness, consistent with strength, vibrate like tuning forks in response to frequencies that travel faster than sound through the increasingly energized atmosphere. Their calls to each other take on new urgency as air currents that have carried them with thermal precision for their entire lives begin to move in patterns that speak of vast disturbances in places beyond the horizon. The largest of these aerial giants, a male whose wingspan could shadow a modern school bus, banks into a turn that gives him a better view of the northern sky. What he sees there challenges every pattern his nervous system has learned to recognize as normal. The star that should not exist continues to grow brighter, and now he can perceive its movement, its purposeful approach toward the world that has been his kind's domain since before the first flower opened its petals to ancient sunlight. Miles away, in deeper forest where the canopy filters sunlight into cathedral dimness, a Tyrannosaurus rex matriarch pauses mid-stride in her morning hunt. She is a predator perfected by millions of years of selective pressure, her senses attuned to every nuance that might reveal the presence of prey or rival. Her massive head, armed with teeth that can crush bone like twigs, turns skyward in response to instincts that speak of change on a scale beyond any seasonal variation. Through the forest canopy, she can see fragments of sky, and in those fragments, the growing brilliance that has begun to outshine the sun itself. Her amber eyes, each one larger than your entire hand, track this celestial visitor with the same focused attention she normally reserves for the movement of potential prey through distant undergrowth. Some deep part of her predator's brain recognizes that this light carries implications beyond any earthly threat she has ever faced. Around her, the forest itself begins to respond to changes that move faster than any natural process. Leaves that opened this morning to capture their daily ration of sunlight begin to curl at their edges as the quality of light itself transforms. The radiant energy reaching them from the approaching visitor carries wavelengths that no terrestrial plant has ever evolved to process, creating chemical responses that have no precedent in the billion-year history of photosynthesis. Near a lake that mirrors sky in its still surface, a herd of sauropods lifts their impossibly long necks in unison. Like a forest of fleshy trees reaching toward light that grows stranger with each passing moment. These gentle giants, some weighing as much as modern whales but carrying their mass on legs that have learned to distribute such loads across yielding earth, represent the ultimate expression of herbivorous success. Their calls to each other vibrate through ground and air alike, subsonic communications that carry emotional content across distances measured in miles. What they communicate now is not alarm but wonder, a shared recognition that their world is experiencing something beyond the range of seasonal change or weather variation, or any of the cyclical processes that have governed their long lives. The lake they drink from begins to show the first signs of atmospheric change. Its surface, normally stirred only by gentle breezes that carry the scents of flowering plants and fresh earth, begins to ripple in response to pressure waves that travel through air superheated by the approach of our cosmic visitor. Steam begins to rise from water that has never known temperatures beyond the range of natural climate variation, creating mists that twist and spiral in ways that follow no familiar pattern. As the morning progresses, the celestial visitor grows from impossible star to visible object, its form resolving into something that challenges every category their brains have evolved to recognize. It is neither bird nor insect, neither cloud nor any familiar aerial phenomenon. It moves with purpose, but produces no sound, grows larger with each passing moment, but follows trajectories that obey no earthly physics they have ever observed. The Triceratops family, now joined by others of their kind drawn by alarm calls that carry for miles through the forest, forms a loose herd that faces northward toward the approaching visitor. Their instinctive response to unprecedented threat is to gather together to present the unified front of horns and armored frills that has protected their lineage through millions of years of successful survival. But this visitor approaches from an angle no earthly predator has ever used, from heights no terrestrial threat has ever achieved, with purposes that exist entirely outside the familiar categories of territorial challenge or resource competition, or any of the evolutionary pressures that shape their defensive strategies. The thermal pulse reaches them first, traveling at the speed of light from the moment of impact that is still minutes away. The forest begins to glow, not with the familiar warm radiance of sunlight filtered through leaves, but with the harsh brilliance of matter heated beyond the normal limits of earthly chemistry. Leaves begin to smolder, then burst into flame as the radiant energy washes over them like an invisible tide of fire. Yet there is something almost gentle about this process. The creatures caught in this unprecedented event do not suffer, as we might imagine suffering. The transformation occurs too quickly for pain, too completely for any prolonged awareness of change. In one moment, they are living beings, complex arrangements of carbon and water and calcium forged by millions of years of evolutionary refinement. In the next, they are part of the expanding wave of energy that carries the signature of cosmic collision outward into a world unprepared for such fundamental change. The Triceratops matriarch, whose wisdom has guided her family through drought and plenty, through the long winters when food becomes scarce, and the abundant summers when every plant offers sustenance, feels the first touch of heat that exceeds the tolerance of any earthly metabolism. Yet her final moment is not one of fear but of wonder. her ancient eyes reflecting light from a sky that has become brighter than any sun. Her mate and offspring, pressed close against her in the instinctive formation that has protected their kind for millions of years, share this final wonder together. Their calls to each other, voiced in the last seconds before atmospheric conditions make sound impossible, carry not distress but something that might almost be interpreted as greeting, as if they recognize in this cosmic visitor a force too large for resistance, too fundamental for fear. The Tyrannosaurus, apex predator of an age that is ending with each passing second, stands motionless in a forest clearing as the wave of superheated air reaches her position. Her massive form, perfected by selective pressures that favored size and strength and intelligence, faces this unprecedented challenge with the same calm patience that characterized her species' reign over the terrestrial ecosystem. In her final moment, she embodies everything that made the age of dinosaurs magnificent: the marriage of power and grace, the perfect adaptation to environmental niches that will never exist again, the successful exploration of body plans and life strategies that pushed the boundaries of what complex life could achieve on a planet rich in possibilities, the hadrosaurs by their stream, the sauropods by their lake, the small arboreal dinosaurs in their canopy territories, the pteranodons soaring high above the transforming landscape, all experience the same gentle transition from complexity to simplicity, from the intricate arrangements of molecules that spelled life to the elemental state that underlies all terrestrial chemistry. Yet in these final moments, I sense something that transcends individual loss. These creatures, in giving up their hold on terrestrial existence, make room for new experiments in the ancient laboratory of evolution. Their carbon will become part of new atmospheric cycles. Their calcium will help build new reef systems in future oceans. Their very atoms will be recycled into the bodies of creatures not yet imagined by the creative forces that drive biological change. The forests that sheltered them, the lakes that reflected their forms, the air that carried their calls across landscapes of unimaginable beauty, all undergo the same transformation. But this is not destruction but metamorphosis, not ending but preparation for new beginnings, not loss but investment in futures that will explore possibilities foreclosed by the very success of the age that is ending. As the thermal pulse completes its work, as the superheated atmosphere transforms living tissue into component elements, as the age of giants draws to its close in a crescendo of light and heat and change that circles the globe in hours, I am struck by the profound dignity with which these creatures meet their cosmic appointment. They do not rage against forces beyond their comprehension. They do not struggle against transformation that occurs too quickly for struggle. They simply continue to be themselves, fully and completely, until the moment when being themselves is no longer possible in the new conditions that our visitor from space has brought to their ancient world. This is how giants say farewell, not with noise and violence and desperate resistance, but with the same quiet grace that characterized their 165 million year stewardship of Earth's terrestrial ecosystems. They step aside with dignity intact, making room for the smaller, more adaptable creatures that will inherit the world their ending makes possible. And in that stepping aside, in that graceful yielding to forces too large for any individual resistance, they achieve a kind of immortality that no amount of struggle could have won. They become part of the transition itself, contributors to the great change that will reshape life on Earth in ways that honor both what was and what will be. The energy released by the cosmic impact does not dissipate but transforms, spreading outward through every medium our planet offers with a violence that makes earthly storms seem like gentle breezes. in the first moments after contact, the force that vaporized limestone and visitor alike seeks every possible path of release, flowing through rock and air and, most spectacularly, through the warm, shallow seas that surround the impact site like a series of interconnected aquatic highways. I follow the birth of the first tsunami as it forms in the superheated waters directly above the impact crater. This is not the familiar rise and fall of wind-driven waves, nor even the dramatic surge of earthquake-generated tsunamis that occasionally reshape coastal regions. This is something unprecedented in Earth's recent history, a wall of liquid energy that rises not from the displacement of sea floor, but from the instantaneous vaporization of millions of tons of seawater and the explosive rebound of rock compressed beyond its elastic limits. The wave that forms is initially indistinguishable from the expanding fireball itself. Water and vapor and superheated steam form a single medium, unified by temperatures that reduce all normal boundaries between states of matter to meaningless distinctions. This liquid fire rises from the impact site like a fountain, with the power to reach orbital altitudes, carrying within its substance the dissolved remains of coral reefs and limestone sediments and countless creatures that were transformed from living beings to component atoms in the space of milliseconds. As this column of energized matter reaches its maximum height and begins to fall back toward the Earth's surface, it creates the sea from which the tsunamis will grow. The water that returns to the sea carries with it momentum borrowed from the cosmic impact itself, energy that was forged in the depths of space during a 165 million year journey, and is now expressed as liquid motion that will circle the globe multiple times before finding rest. The first recognizable wave forms at the boundary between the superheated central column and the surrounding waters that have been heated but not vaporized. Here, where temperatures drop from stellar to merely volcanic, the expanding shock front begins to behave like liquid rather than gas, forming a wall of water that rises from the normal sea surface like a liquid mountain moving at velocities that challenge the speed of sound itself. I rise with this wave as it builds, watching it grow from dozens of feet to hundreds, then to heights that dwarf any geographical feature in the surrounding landscape. The wavefront, perfectly circular at first, spreads outward from the impact crater with geometric precision, its leading edge moving at speeds approaching 500 miles per hour through water that offers no resistance to forces of such magnitude. The water that forms this tsunami is not ordinary seawater, but a complex mixture of the original ocean, vaporized limestone, shocked minerals created in the first moments of impact, and the actual substance of our cosmic visitor, now dissolved into ionic form and distributed throughout the liquid medium. This water carries within its molecular structure the memory of pressures found only in planetary cores and temperatures that exist normally only in the hearts of stars. As the wave races outward, it encounters the first obstacles to its passage. Islands that have stood above sea level for millions of years, their surfaces crowned with forests that have never known the touch of salt water, disappear beneath the advancing wavefront without slowing its progress by so much as a fraction of a second. The water simply rises over them, carrying away entire ecosystems and depositing them in locations hundreds of miles inland when it finally comes to rest. A colony of pteranodons nesting on coastal cliffs that have provided safe rookery sites for countless generations takes to the air in response to the strange rumbling that precedes the wave's arrival. Their keen eyesight, evolved to spot fish from great heights, can see the approaching wall of water while it is still miles away, but their brains cannot process the scale of what they observe. From their aerial vantage point, They watch as their familiar coastline is transformed in minutes. Beaches where they have fed on stranded fish for their entire lives disappear beneath water that rises with the inexorable persistence of geological change compressed into moments. The cliffs themselves, carved from limestone by millions of years of patient wave action, crumble and dissolve as the tsunami's superheated waters attack rock already weakened by the thermal pulse that preceded the wave's arrival. But the pteranodon's flight carries them beyond the reach of even this unprecedented surge. They spiral upward on thermal currents created by the collision itself, riding columns of superheated air that rise from the impact site like invisible mountains. From these heights, they can see the entire Gulf of Mexico being reshaped by forces that exceed any earthly comparison. Watch as familiar landmarks disappear beneath walls of moving water that advance with mechanical precision across a geography that has remained stable for millions of years. The tsunami's advance into shallower water creates new phenomena as the wave encounters the gradually rising sea floor that marks the transition from deep ocean to continental shelf. The physics of wave propagation requires that the incredible energy carried by the water be compressed into smaller volumes as depth decreases, and this compression transforms the already massive wave into something that challenges the imagination. Where the water is deep, the tsunami passes almost unnoticed, its energy distributed through the entire water column from surface to sea floor. Marine creatures living in these depths experience the wave's passage as nothing more than an unusual current, a temporary acceleration in the normally sluggish movement of deep water. Ammonites continue their spiral dances, unaware that above them races a wave carrying enough energy to level mountain ranges. But as the tsunami approaches the shallow seas that surround the impact site, the mathematics of hydrodynamics begin to work their transformation. The wavefront, moving faster than any earthly current has ever moved, encounters water depths that force its energy upward, concentrating the horizontal momentum into vertical displacement that builds with each mile of shallowing sea floor. I watch this transformation with a mixture of awe and something approaching reverence. The wave, which began as a relatively modest rise in deep water, grows with each foot of depth reduction. 100 feet becomes 200, 200 becomes 500, 500 becomes 1,000 feet of vertically moving water that carries within its liquid bulk the accumulated energy of the cosmic impact itself. This is no longer simply a tsunami, but a temporary rearrangement of ocean and atmosphere, a liquid mountain that moves across the Earth's surface with the momentum of celestial mechanics. The wavefront catches and reflects sunlight like a moving mirror, its surface tension creating optical effects that have never before existed on Earth's surface, rainbows that arc through spray, lifted to altitudes normally occupied only by clouds, reflections that create multiple images of the sun scattered across the wave's advancing face. When this liquid mountain encounters the first coastal plains, the result is not violent collision, but something more like absorption. The land simply disappears beneath water, moving with such momentum that normal concepts of shoreline and beach and tidal zone become meaningless. Forests that have stood for thousands of years are swept away, not by the impact of the wave, but by its passage, carried along in currents that transport entire ecosystems to locations where they will form fossil deposits that will puzzle paleontologists for millions of years to come. A family of hadrosaurs, grazing in coastal wetlands where fresh water meets salt, experiences the arrival of the tsunami not as a wall of approaching water, but as a gradual realization that their familiar feeding grounds are being transformed into something aquatic. The water rises around them with the inevitability of high tide, compressed into minutes, rather than ours, carrying them along in currents that are surprisingly gentle despite their unprecedented power. These duck-billed giants, adapted to life at the boundary between terrestrial and aquatic environments, find themselves swimmers in water that carries them far from their birthplace. Their calls to each other, normally used for territorial communication and family coordination, now serve to maintain contact as they are transported by forces beyond any earthly experience toward destinations determined by the mathematics of fluid dynamics, rather than their own navigational choices. The tsunami's advance inland is limited only by topography and its own momentum. Where the land is flat, water penetrates hundreds of miles from the normal coastline, transforming entire states into temporary inland seas. Where mountains or high plateaus block its path, the wave expends its energy in spectacular displays that create waterfalls of unprecedented scale, temporary Niagaras that exist for mere hours before the water finds new channels toward lower ground. But the most remarkable aspect of this aquatic invasion is not its violence, but its temporary nature. The same forces that drive the water inland also ensure its eventual return to the ocean basins where it belongs. As the tsunami's momentum dissipates through friction with the landscape it traverses, gravity begins to assert its eternal claim, drawing the displaced water back towards sea level through whatever channels it can find or create. This return journey carves new river valleys, creates temporary lakes in low-lying areas, and deposits layers of marine sediment hundreds of miles from any normal shoreline. When the water finally recedes, it leaves behind a landscape transformed not just by its passage, but by the materials it carried. Limestone fragments from the impact crater, shock minerals created in conditions that exist nowhere else on Earth's surface, and the fossilized remains of creatures caught in the greatest transportation event in the planet's recent history. The effects extend far beyond the immediate impact region. The tsunami's energy, though diminished by its interaction with shallow seas and coastal plains, continues its outward journey into the deeper ocean basins where different physics govern its behavior. Here, in water depths measured in miles rather than feet, the wave regains its ability to travel at velocities approaching that of sound, carrying news of the cosmic collision to shores thousands of miles from the point of impact. I follow one of these deep water waves as it races across what will one day be called the Atlantic Ocean, moving toward coastlines that have never experienced anything beyond the normal variations of tide and weather. The wave travels beneath the surface now, its energy distributed through the water column in ways that make its presence almost invisible from above. Only the most sensitive marine creatures, those adapted to detect the slightest changes in water pressure and current direction, can sense its approach. Schools of primitive fish, their lateral line systems detecting pressure variations that speak of approaching change, begin to move in patterns that have no precedent in their genetic memory. They form spirals and waves and complex geometries that mirror the advancing tsunami's mathematical structure, as if they have become living expressions of the hydrodynamic forces that will soon reshape their underwater world. When this transoceanic tsunami finally encounters the distant shores of Africa and Europe, it arrives with force diminished, but still capable of rewriting coastlines that have remained stable since the continents achieved their current positions. Ancient river mouths are scoured clean. Prehistoric beaches are buried beneath layers of sediment carried from the impact site, and marine terraces are carved into limestone cliffs by water that carries within its substance the actual atoms of our cosmic visitor. The global nature of these effects becomes apparent as similar waves, traveling in all directions from the impact site, encounter every ocean basin on the planet. the Pacific receives its own tsunami, one that crosses the entire breadth of that vast ocean to deposit impact debris on shores that will not be recognized by human eyes for millions of years. The young Atlantic, still narrow compared to its modern width, becomes a conduit for water that carries the signature of cosmic collision from the Caribbean to the coasts of ancient Europe and Africa. But perhaps the most significant aspect of these global tsunamis is their role in distributing the impact's effects to parts of the planet that would otherwise have remained untouched by the cosmic collision. The water that eventually recedes from temporarily flooded continents leaves behind a chemical calling card, a layer of sediment enriched with iridium and shocked minerals that will provide future scientists with evidence of this global transformation. As the hours pass and the tsunamis complete their circumnavigation of the globe, their energy gradually dissipates into heat and friction, returning the oceans to something resembling their normal state. But the planet they lap against has been fundamentally altered. Coastlines have been redrawn, sediment layers have been deposited far from their points of origin, and marine ecosystems have been transported to locations where their fossilized remains will tell stories of this day for millions of years to come. The waters themselves carry a new chemistry, enriched with elements that normally exist only in the planet's deep interior or in the hearts of asteroids. This chemical signature will influence biological processes for generations, providing new raw materials for evolutionary experimentation while challenging existing life forms with environmental conditions that have no precedent in Earth's history. In the aftermath of these aquatic upheavals, as the temporary seas drain back toward their permanent basins, and the displaced water finds new equilibrium in ocean basins that have been permanently altered by the day's events, a transformed world emerges. It is a planet where familiar landmarks have been erased, where entire ecosystems have been redistributed by forces that dwarf any earthly comparison, where the very chemistry of the oceans has been altered by the addition of cosmic ingredients. Yet in this apparent chaos, I can perceive the seeds of new order. The redistribution of sediments will create new habitats for the life forms that survive the transition. The altered ocean chemistry will drive new evolutionary pathways for marine organisms. The carved valleys and temporary lakes will become nurseries for species that have yet to emerge from the creative laboratories of genetic change. The oceans have moved, carrying with them the memory of a cosmic appointment kept with geological precision. In their movement, in their temporary transgression of ancient boundaries, in their eventual return to basins that have been forever altered by their displacement, they write in liquid script the story of the day when sky and sea and stone collaborated in the transformation of an entire world. As I drift through the aftermath of this cosmic encounter, suspended between the world that was and the world that is becoming, I am struck by profound truths that connect this ancient moment to your own modern existence in ways that span not just space, but the very essence of what it means to be alive on a planet that has known such transformations. You who listen to this story carry within your very atoms the legacy of this day. The calcium in your bones was once part of limestone formations that witnessed the approach of our cosmic visitor. The iron in your blood was forged in stellar cores and delivered to Earth by wanderers from deep space, perhaps including fragments of our 6-mile messenger that scattered into the atmosphere and eventually found their way into the biological cycles that would, 66 million years later, contribute to your physical form. Every breath you take contains oxygen that was liberated from water molecules vaporized in the first moments of impact. Every beat of your heart pumps blood enriched with elements that were once part of creatures whose final moments I have just witnessed. The very carbon that forms the backbone of your DNA was once dispersed through a superheated atmosphere, part of the great recycling that prepared the planet for new experiments in the architecture of life. But the connection runs deeper than chemistry, profound though that chemistry may be. In the gentle way the giants faced their ending, in their lack of struggle against forces beyond their comprehension, in their quiet acceptance of transformation that was both ending and beginning, you can recognize something that speaks to the deepest wisdom available to conscious beings. Consider the patience required for this cosmic appointment to occur. 165 million years of wandering through space, following gravitational influences too subtle for immediate perception, adjusting course through interactions with forces that work on timescales beyond any individual consciousness. The asteroid that became our visitor practiced a form of patience that makes human concepts of persistence seem like momentary enthusiasms. Yet that same patience lives within you. Your existence represents the successful completion of an unbroken chain of survival and reproduction that stretches back not just to the aftermath of the impact we have witnessed, but to the very origins of life on this planet. Every ancestor you have ever had, from the first self-replicating molecules in primordial seas to the mammals that inherited the post-impact world, successfully navigated challenges that would have ended their genetic lineage, if not for the kind of patient adaptation that our cosmic visitor embodied in its long journey home. The Triceratops matriarch who faced the approaching light with curiosity rather than fear demonstrates something essential about how conscious beings can meet unprecedented change. She did not waste energy raging against transformation beyond her control. She did not exhaust herself in futile attempts to prevent the unpredictable. She simply continued to be herself, fully and completely, until the moment when being herself was no longer possible under the new conditions that the universe had decreed. In your own life, you face changes that arrive with cosmic suddenness, transformations that remake your personal landscape as thoroughly as the tsunamis remade the geography of the Cretaceous world. The loss of loved ones, the ending of relationships, the conclusion of careers or phases of life that seemed as permanent as geological features, all of these partake of the same fundamental process that we have witnessed in deep time. What the dinosaurs teach us is that dignity lies not in preventing change, but in meeting it with the full presence of whatever we are in each moment. The Tyrannosaurus did not cease to be an apex predator when faced with forces that dwarfed her individual power. The sauropods did not abandon their gentle grace when their familiar world began to transform beyond recognition. They remained themselves completely until the last possible moment, and in that remaining, they achieved a kind of immortality. You carry their legacy not just in your bones and blood, but in your capacity to meet your own endings with similar grace. Every day you practice small versions of their final acceptance, when you allow sleep to carry you into unconsciousness, when you let the seasons change your familiar landscape, when you watch children grow beyond your ability to protect them, when you accept that each moment is simultaneously arrival and departure. The impact that ended the age of giants also ended the conditions that made their size and their strategies successful. But it did not end life itself, nor the creative forces that drive biological innovation. The same event that closed one chapter of Earth's story opened countless others, creating opportunities for experiments in living that had been foreclosed by the very success of the creatures whose ending we have witnessed. Your mammalian ancestry traces directly to small, adaptable creatures that survived the impact not through size or strength, but through flexibility, through the ability to find sustenance in changed conditions, through reproductive strategies that allowed rapid adjustment to new environmental pressures, in your capacity for learning, for cultural adaptation, for technological innovation that allows you to thrive in conditions that would have challenged any previous form of life. You embody the very qualities that made survival possible in the post-impact world. But perhaps the most profound connection between that ancient day and your present existence lies in the recognition that endings and beginnings are not separate processes, but aspects of the same cosmic creativity. The death of the giants was simultaneously the birth of new possibilities. The vaporization of ancient limestone was simultaneously the liberation of carbon that would fuel new atmospheric cycles. The extinction of dominant species was simultaneously the opening of ecological niches that had been waiting millions of years for their occupants. In your own life, you experience this same truth whenever you allow something that no longer serves your growth to end naturally, making space for new possibilities to emerge. The relationships that conclusion with grace become the foundation for deeper connections. The careers that end when their lessons have been learned become launching points for contributions that were impossible under the previous circumstances. The identities that you outgrow become compost for more authentic expressions of who you are becoming. The cosmic visitor that kept its appointment with Earth 66 million years ago was not separate from the planet it transformed, but was, in a sense, coming home to matter that had been separated during the solar system's formation. Its arrival was not invasion, but reunion, not destruction, but integration. The violence of the impact was the necessary pressure required to blend ingredients that had been kept apart by the normal processes of planetary formation. Similarly, the changes that seem to arrive in your life from outside your control often carry within them elements that have been seeking integration for longer than your conscious mind has been aware of their need. The challenges that test your adaptive capacity, the losses that force you to discover resources you did not know you possessed, the opportunities that require you to expand beyond your previous definitions of yourself, all participate in the same creative process that transformed our planet from a world of giants to a world capable of supporting the complexity of modern ecosystems. The patience of the asteroid teaches us about the way cosmic forces work through timescales that challenge individual comprehension. But you practice versions of that same patience whenever you plant seeds without knowing exactly what will grow, whenever you invest love in relationships without guarantees about their duration, whenever you pursue studies or practices or creative works whose full benefits may not become apparent for years or decades. The heat that transformed living creatures into component atoms and then into new arrangements of matter mirrors the way your own cells are constantly dying and being reborn, the way your thoughts and emotions and memories are continuously being reorganized by experiences that challenge your previous understanding. You are not the same person who began listening to this story, just as the Earth was not the same planet after its encounter with our cosmic visitor. The gentleness with which the giants met their ending reflects a wisdom that is available to you in every moment of transition. Whether facing changes as dramatic as the ones we have witnessed or as subtle as the passage from one breath to the next, you have the opportunity to embody the same kind of presence, the same willingness to be fully yourself, while allowing transformation to occur according to principles larger than individual preference. The global effects of the impact, the way changes that began in one small area of ocean eventually influence weather patterns and biological processes across entire continents, remind us that nothing exists in isolation. Your own choices, your responses to the changes that arrive in your life, your willingness to meet endings with grace and beginnings with openness, ripple outward through networks of connection that span generations and continents, and possibly even geological ages. The iridium layer that marks the boundary between the Cretaceous and Paleogene periods will remain as evidence of this cosmic encounter for as long as Earth's geological processes preserve the rock record. Similarly, the ways you choose to meet your own transitions leave lasting traces in the lives of everyone you touch, contributing to cultural and emotional sediments that will influence generations not yet born. In the end, the most profound human connection to this ancient day lies in the recognition that you are not merely a product of the forces that shaped our planet, but a participant in their ongoing creative work. Your consciousness, your capacity for wonder at cosmic processes, your ability to find meaning in events separated from you by millions of years, these represent new developments in the universe's exploration of what is possible when matter becomes sufficiently organized to contemplate its own origins and destiny. The dinosaurs ruled the Earth for 165 million years, a span of time that dwarfs the entire history of human civilization. Yet, in the few thousand years of recorded human history, we have developed the ability to understand and appreciate their story, to reconstruct the conditions of their world, to honor their contribution to the larger narrative of life on Earth. We have become the memory keepers, the witnesses to deep time, the consciousness through which the universe can reflect on its own processes. This capacity for deep time awareness, for finding personal meaning in cosmic processes, for allowing ancient events to inform present choices, this is your inheritance from the day the sky fell, and the age of giants ended with such quiet grace. You are not just made from the atoms of that transformation, but called to embody its wisdom, to practice its patience, to meet your own changes with similar dignity. As the immediate violence of the impact fades into the longer rhythms of planetary adjustment, I find myself witnessing the gradual emergence of a world transformed beyond recognition, yet still fundamentally the same Earth that has nurtured life for billions of years. The echoes of our cosmic visitor's arrival will resonate through atmospheric and oceanic systems for centuries, but already the patient forces of healing and adaptation have begun their ancient work. The superheated atmosphere that made life impossible across vast regions of the planet begins to cool as the energy of the impact disperses into the cold depths of space. The fires that ignited spontaneously across continents burn themselves out as their fuel is consumed, and atmospheric conditions return to ranges that allow normal chemical processes to resume. The debris that reached orbital heights begins its slow return to Earth, no longer as molten projectiles, but as a fine dust that settles like cosmic snow across landscapes still smouldering from the day's transformations. I drift through air that carries the mixed signatures of ending and beginning. The particulates suspended in the atmosphere include not just the vaporized remains of limestone and asteroid, but organic compounds from forests that existed just hours before, now transformed into carbon molecules that will feed new cycles of photosynthesis when conditions permit plants to resume their ancient partnership with sunlight. The quality of light itself has changed. The fine dust and aerosols thrown into the stratosphere by the impact create atmospheric conditions that will persist for years, filtering sunlight through veils of cosmic debris that produce sunsets of unprecedented beauty and strangeness. The sky takes on colors that have no names in any earthly language, deep purples that grade into burnished copper, greens that shimmer with metallic brilliance, golds that seem to glow with inner fire. These atmospheric effects, spectacular though they appear, represent challenges that will test every surviving life form's capacity for adaptation. The reduced sunlight reaching Earth's surface will make photosynthesis difficult for plants that evolved under the clear skies of the Cretaceous world. Temperatures will drop as the planet's energy balance shifts, creating climate conditions that have no recent precedent in geological history. Yet even as I observe these challenges, I can sense the resilience that life has developed through billions of years of surviving catastrophes, both gradual and sudden. In protected valleys, where atmospheric heating was less severe, in underground burrows where mammals and other small creatures waited out the initial chaos, in deep ocean environments where thermal effects penetrated slowly, communities of survivors begin the patient work of reclaiming their world. A small mammal, no larger than a modern rat, but carrying within its genetic structure the potential for forms of life that will not emerge for millions of years, ventures from the burrow where it sheltered during the day's unprecedented events. Its whiskers twitch as it tests air that tastes of smoke and strange minerals, its dark eyes scanning a landscape transformed beyond the recognition of any previous generation of its species. The forest that provided its familiar landmarks has been replaced by a moonscape of ash and debris. But this creature's ancestors survived the gradual cooling that ended earlier warm periods. The volcanic eruptions that periodically reshaped local landscapes, the seasonal changes that required constant adaptation to shifting resource availability. Its brain, small but incredibly flexible, begins immediately to process new information and adjust behavioral patterns to match the unprecedented conditions it encounters. This capacity for rapid behavioral adaptation will prove more valuable than size or strength in the world that is emerging from the impact's aftermath, where the giants relied on established patterns refined over millions of years of evolutionary success. The survivors must improvise solutions to challenges that have no precedent in their genetic memory. Near a stream whose waters run cloudy with sediment carried from the impact site, a small dinosaur, one of the few large creatures to survive the initial thermal pulse by virtue of being in exactly the right place at the right moment, approaches the water with the caution that will characterize all life in the months and years to come. This is a creature caught between worlds, carrying genes adapted to the Cretaceous environment, but forced to live in conditions that resemble no previous period in Earth's history. The water it drinks carries dissolved minerals from rock formations that were buried for millions of years before being exposed by the impact's violence. These chemical changes will influence biological processes in ways both subtle and profound, providing new raw materials for evolutionary experimentation, while challenging existing organisms with environmental chemistry that has no recent precedent. As days pass, the full global scope of the transformation becomes apparent. The impact winter, caused by particulates blocking sunlight, begins to affect weather patterns across the entire planet. Temperatures drop not gradually, as in normal seasonal change, but rapidly enough to stress ecosystems that evolved under the stable, warm conditions of the late Cretaceous. Yet this cooling also creates opportunities. Ice begins to form at polar latitudes for the first time in millions of years, locking up water that had circulated freely through the global ocean system. As sea levels drop, new land bridges emerge between continents that had been separated by shallow seas, creating migration corridors that will allow surviving species to colonize new territories and escape regions where local conditions have become unlivable. The Western Interior Seaway, that vast body of water that split North America into eastern and western islands throughout the age of dinosaurs, begins to drain as global sea levels drop, and continued geological uplift raises the continent's central regions above water level. This change alone will reshape the continent's climate, creating the vast grasslands that will, millions of years in the future, support herds of mammals as impressive in their own way as the dinosaur communities they replace. In the oceans, the effects of the impact continue to work themselves through marine ecosystems with the thoroughness that characterizes all major environmental changes. The ammonites, those beautiful spiral-shelled creatures that ruled marine environments for hundreds of millions of years, find their reproductive cycles disrupted by changes in water temperature and chemistry. Their populations, already stressed by the immediate effects of the impact, begin the decline that will lead to their complete extinction within a few million years. But their disappearance creates opportunities for other marine organisms. Small shellfish, less specialized in their dietary requirements and reproductive strategies, begin to expand into ecological niches left vacant by their larger, more complex competitors. These humble creatures, unremarkable by the standards of Cretaceous marine life, carry within their genetic structure the potential for forms that will eventually give rise to some of the ocean's most successful modern species. The coral reefs that were vaporized in the immediate impact zone begin a process of recovery that will take millions of years to complete. But even as the old reef systems disappear, new forms of coral, adapted to the changed chemistry of seawater enriched with cosmic minerals, begin to experiment with growth patterns and symbiotic relationships that will eventually produce reef ecosystems more diverse and resilient than those they replace. On land, the process of recovery follows patterns established by previous mass extinctions, but compressed into timeframes that challenge normal concepts of geological change. In regions where the thermal pulse was less severe, plants begin to emerge from root systems that survived underground while their surface structures were destroyed. These early pioneers, mostly ferns and other spore-bearing species, adapted to rapid colonization of disturbed ground, create the first green patches in a landscape that has been reduced to mineral browns and greys. As vegetation returns, it creates habitat for the small animals that form the foundation of recovering ecosystems. Insects, with their short generation times and ability to exploit specialized food sources, adapt quickly to change conditions. Their populations explode in the absence of larger competitors, creating the abundant food supply that will support the mammals and birds, whose rapid diversification will characterize the post-impact world. The birds, descendants of the small dinosaurs that survived the extinction, embody the continuity that connects the age of giants with the age of warm-blooded diversity that is beginning to emerge. They carry forward not just dinosaurian anatomy and physiology, but behaviors and ecological strategies that prove successful enough to survive the most severe environmental challenge of the past 100 million years. Watching these early birds as they explore the transformed landscape, I am struck by how they represent both ending and beginning. Their hollow bones and feathered wings connect them directly to the pterosaurs and small dinosaurs whose final moments I witnessed. Yet their rapid adaptations to new food sources and nesting sites demonstrate the flexibility that will allow life not just to survive, but to flourish in the post-impact world. The mammals, those small, warm-blooded creatures that lived in the shadows of the giants, find themselves inheriting a world suddenly full of opportunities. The ecological niches that were occupied for millions of years by specialized dinosaur species are now vacant, waiting for new occupants. Over the coming millions of years, mammalian evolution will explore body plans and life strategies that parallel those of the extinct dinosaurs, creating saber-toothed predators, massive herbivores, and creatures adapted to every conceivable terrestrial environment. But the most significant change is not in the species that survive, but in the conditions that will shape their evolution. The impact has created a world where adaptability matters more than specialization, where rapid response to changing conditions provides greater survival advantages than perfect adaptation to stable environments. This shift will drive evolutionary processes toward increased intelligence, behavioral flexibility, and social cooperation in ways that the stable Cretaceous world never required. As months pass and the immediate effects of the impact fade into long-term environmental changes, I sense the approach of something unprecedented in Earth's history. The mammals, freed from competition with giant reptiles and driven by selection pressures that favor intelligence and adaptability, begin the evolutionary journey that will eventually produce consciousness, capable of understanding cosmic processes, of finding meaning in deep time, of reconstructing and honoring the story of the day the sky fell. The dust begins to settle, both literally and metaphorically. The fine particles that blocked sunlight and created the impact, winter gradually worked their way out of the atmosphere, settling onto landscapes where they form a thin layer that will mark this moment in geological time for as long as Earth's rock record persists. Future geologists will recognize this boundary layer, enriched with iridium and shocked minerals, as evidence of the day when cosmic and terrestrial forces collaborated in the transformation of an entire world. As sunlight begins to penetrate the clearing atmosphere with something approaching its normal intensity, photosynthesis resumes on a global scale. Plants that survived in protected environments begin to spread their descendants across continents that offer vast areas of disturbed ground ideal for pioneer species. The green that was largely absent from Earth's surface for months begins to return, at first in scattered patches, then in expanding networks that will eventually reconnect into the continuous forest systems that characterize the planet before the impact. Yet this returning green is different from what came before. The plant species that thrive in the post-impact world are those adapted to rapid growth, efficient seed dispersal, and tolerance for environmental variability. The stable, specialized plant communities that supported the complex food webs of the Cretaceous are replaced by more dynamic, resilient systems that can recover quickly from disturbance and adapt rapidly to changing conditions. This transformation in plant communities drives corresponding changes in animal communities. The large, specialized herbivores that required vast quantities of specific plant species are replaced by smaller, more generalized feeders that can extract nutrition from whatever vegetation is available. These dietary generalists, in turn, support carnivores that are more behaviorally flexible than their predecessors, capable of hunting diverse prey species and adapting their techniques to changing circumstances. The predator-prey relationships that characterize the emerging ecosystems are more complex and dynamic than those of the Cretaceous world, where tyrannosaurs relied primarily on size and power to overwhelm their prey. The mammalian carnivores that will eventually dominate terrestrial ecosystems develop intelligence, cooperation, and behavioral flexibility as their primary weapons. This shift toward mental rather than physical solutions to survival challenges sets the stage for the eventual emergence of consciousness, capable of contemplating its own origins. As years pass and the transformed world settles into new patterns of stability, I begin to sense the approach of a fundamental transition in Earth's story. The impact that ended the age of giants has also created conditions that will eventually produce forms of life capable of understanding the very processes that created them. The consciousness that will one day reconstruct this story and find in it meanings that transcend individual survival is already implicit in the selection pressures that favor intelligence and adaptability in the post-impact world. The returning rains, no longer superheated by atmospheric debris, wash the cosmic dust from leaves and rocks, carrying it into streams that will eventually deposit it in ocean sediments, where it will join the geological record of Earth's long history. But the influence of our cosmic visitor extends far beyond the physical particles it contributed to terrestrial chemistry. The impact has reset Earth's biological clock, opening new chapters in the story of life that had been foreclosed by the very success of the creatures whose ending we witnessed. The age of giants gave way gracefully to an age of intelligence, an age of creativity, an age of consciousness capable of finding beauty and meaning in the cosmic processes that shaped both the planet and the life it supports. Now, as I prepare to guide your awareness back to your own time and place, I am struck by the continuity that connects this ancient transformation to your modern world. You are not merely descended from the survivors of this cosmic encounter, but are, in a very real sense, its ultimate purpose. Consciousness capable of understanding deep time, of finding personal meaning in planetary processes, of honoring both what was lost and what was gained in the moment when sky fell to earth and earth rose to meet it. The fading echo of the impact speaks through every aspect of your existence, from the mammals that warmed their bodies with the same metabolic fires that allowed your ancestors to survive the impact winter, to the intelligence that allows you to reconstruct and appreciate the story of that ancient day. You are the Earth become conscious of its own history, the universe learning to contemplate its own processes through forms of awareness that the impact helped make possible. In the quiet that follows the storm, in the gentle light that penetrates the clearing atmosphere years after our cosmic visitor kept its ancient appointment with Earth, I witness the most beautiful aspect of this entire transformation. From the apparent ending of one world emerges the beginning of another, not through violence replacing violence, but through the patient creative forces that turn every conclusion into a new commencement. Where the great crater marks the site of impact, life returns with a resilience that speaks to principles more fundamental than any individual extinction or survival. The shocked rock that lines the cavity, mineral structures that exist nowhere else on Earth's surface, provides unique chemical environments that drive new experiments in the ancient laboratories of evolution. Bacteria that learn to process sulfur compounds in deep ocean vents find new opportunities in rocks that have experienced pressures normally found only in planetary cores. These microscopic pioneers, invisible to any eye that might observe them but carrying within their genetic structure solutions to challenges that no terrestrial life has ever faced, begin the patient work of transforming mineral substrates into organic possibilities. They are the first writers in a new chapter of Earth's story, authors of biochemical innovations that will eventually support ecosystems more diverse and resilient than those they replace. Around the crater's rim, where limestone was shocked into new crystalline forms and organic compounds from vaporized forests were preserved in glass, the first plants to colonize the impact site discover soil chemistry, unlike any that evolved during the gradual processes of normal geological time. These pioneer species, drawing nutrition from cosmic minerals and terrestrial rock in combinations that have never before existed, develop adaptations that will prove valuable as similar conditions arise through natural volcanic activity and other geological processes. But the most profound gift of this cosmic encounter lies not in the new chemical possibilities it created, but in the biological opportunities it opened. For 165 million years, the success of giant reptiles foreclosed certain evolutionary pathways, their dominance preventing the exploration of life strategies that require different approaches to problems of growth, reproduction, and environmental adaptation. The mammals that emerge from burrows and tree holes and cave systems, where they waited out the initial chaos, inherit a world suddenly rich with possibilities that had been unavailable to their ancestors. The ecological niches that supported massive herbivores now welcome smaller, more flexible creatures, whose survival depends not on perfecting single strategies, but on developing the capacity to adjust their behavior as conditions require. I watch a small mammal, perhaps ancestral to the creatures that will eventually give rise to primates, exploring the edge of a recovering forest, where new growth pushes through soil enriched with cosmic dust. Its nervous system, adapted to processing complex sensory information and adjusting behavior accordingly, encounters environmental variety that will drive the development of intelligence in ways that the stable Cretaceous world never required. This creature does not know that it carries within its genetic structure the potential for forms of consciousness that will eventually be able to contemplate the very processes that made its existence possible. It simply explores its transformed world with the curiosity that characterizes all successful survivors, gathering information that will guide decisions about food, shelter, and reproduction in an environment that offers both unprecedented challenges and unprecedented opportunities. The intelligence that will one day reconstruct the story of this cosmic encounter is already implicit in the flexibility that allows this small mammal to adjust its behavior to changing conditions. The consciousness that will eventually find meaning in deep time processes is foreshadowed in the sensory awareness that guides its exploration of a landscape transformed by forces larger than any individual comprehension. In the centuries that follow, as the immediate effects of the impact fade into the background conditions that shape long-term evolutionary processes, the true scope of the transformation becomes apparent. The world that emerges from the impact winter is not merely a damaged version of the Cretaceous world, but something entirely new, a planet where intelligence and adaptability provide greater survival advantages than size and specialization. The flowering plants, those relatively recent additions to Earth's terrestrial communities, find their partnership with insects and other pollinators strengthened by the disappearance of large browsers that had limited their expansion into certain environments. Free to colonize landscapes where giant reptiles once prevented their establishment, flowering plants begin the diversification that will eventually produce the grasslands, deciduous forests, and complex plant communities that characterize modern terrestrial ecosystems. With this botanical diversification comes new opportunities for the animals that depend on plant communities for food and shelter. The mammals, no longer restricted to nocturnal existence by the presence of diurnal reptilian competitors, begin to explore daylight niches that drive the development of color vision, complex social behaviors, and cognitive abilities that will eventually produce consciousness capable of aesthetic appreciation. The beauty that will one day be recognized in a sunset, a flower, a piece of music, or a story told across millions of years is already implicit in the sensory systems that develop to navigate environments of unprecedented variety and complexity. The same neural flexibility that allows rapid behavioral adaptation to changing conditions also provides the foundation for the appreciation of patterns and relationships that transcend immediate survival requirements. As millions of years pass, the mammals explore body plans and life strategies that paralleled those of the extinct reptiles, while incorporating innovations that the reptiles never discovered. Social cooperation emerges as a survival strategy that allows smaller individuals to accomplish what giants achieved through individual strength. Communication systems develop that allow the sharing of information across distances and time periods that extend beyond individual lifespans, In the oceans, similar processes drive the evolution of intelligence in entirely different lineages. Cephalopods, freed from predation pressure by the extinction of marine reptiles, begin the exploration of problem-solving abilities and social behaviors that will eventually produce forms of consciousness that humans are only beginning to appreciate. The same cosmic collision that opened terrestrial niches for mammalian intelligence also created marine opportunities for cephalopod cognition. But perhaps the most remarkable aspect of the post-impact world is the way it fosters forms of awareness that can find meaning in processes larger than individual survival. The environmental variability that characterizes the recovering planet drives the development of consciousness that can anticipate future conditions, plan for contingencies that have not yet occurred, and find satisfaction in understanding patterns that extend across vast scales of space and time. The same cosmic appointment that ended the Age of Giants also initiated the Age of Awareness, the geological epoch that will eventually produce minds capable of reconstructing the story of their own origins and finding in that reconstruction not just scientific understanding, but aesthetic pleasure, emotional resonance, and spiritual significance that connects individual consciousness to cosmic processes. As I observe the long-term consequences of this ancient day, I am struck by the profound generosity of the universe's creative processes. The dinosaurs, in stepping aside gracefully when cosmic forces required their withdrawal, made space for forms of beauty and awareness that their continued dominance would have prevented. Their ending was simultaneously a gift to futures they could never have imagined, a contribution to possibilities that required their absence for their realization. The mammals that inherited their world honored this gift by exploring potentials that the reptiles never discovered. Rather than simply replacing giant reptiles with giant mammals, evolutionary processes drove innovations in consciousness, communication, and cultural transmission that created entirely new categories of beauty and meaning in the terrestrial environment. Your own existence represents the culmination of this creative process. You are not merely descended from impact survivors, but are, in the deepest sense, the fulfillment of possibilities that the impact created. Your capacity to find wonder in cosmic processes, to feel reverence for creatures separated from you by millions of years, to discover personal meaning in planetary transformations. These abilities exist because a cosmic visitor kept its appointment with Earth 66 million years ago. The consciousness that allows you to contemplate deep time, the intelligence that enables you to reconstruct ancient events, the emotional sensitivity that lets you find beauty in the story of endings and beginnings. All of these represent evolutionary developments that were made possible by the gentleness with which the giants accepted their transformation and the thoroughness with which cosmic forces cleared space for new experiments in the architecture of awareness. You are the Earth become conscious of its own history, the universe learning to appreciate its own creativity through forms of awareness that no previous geological epoch produced. In your wonder at this ancient story, in your capacity to find meaning that transcends individual survival, in your ability to honor both what was lost and what was gained, you embody the ultimate gift of that day when sky and stone collaborated in the transformation of an entire world. The crater that marks the impact site has long since been buried beneath younger sediments and hidden beneath shallow seas, but its influence extends through every moment of your existence. The intelligence that allows you to understand its story, the consciousness that enables you to find beauty in cosmic processes, the awareness that connects you to events separated by millions of years, all flow from the opportunities that were created when our ancient visitor completed its journey home. As you return now to your familiar world, carry with you the knowledge that you participate in the same creative forces that drove this ancient transformation. Every choice you make that favors adaptability over rigidity, every moment when you meet change with curiosity rather than resistance, every time you find beauty in processes larger than individual preference. In all of these, you honor the legacy of the day the sky fell and new worlds were born from ancient endings. The giants stepped aside with grace, making room for forms of consciousness that could eventually tell their story with appreciation rather than mere scientific analysis. In telling that story with reverence, in finding in their ending the seeds of new beginnings, in recognizing the cosmic creativity that connects their transformation to your own awareness, you complete the circle that began when a wanderer from deep space first felt the gentle pull of Earth's gravity. Sleep now, if sleep is what calls to you, knowing that you rest in a universe where every ending serves new beginnings, where every transformation opens possibilities that could not have existed under previous conditions, where consciousness itself represents the cosmos, learning to contemplate its own beauty through forms of awareness that are simultaneously ancient and eternally new. The parting gift of this ancient day is the recognition that you are not separate from the forces that shaped our planet, but are their latest and most remarkable expression. Matter organized into patterns complex enough to appreciate the very processes that created the conditions for your existence. In that appreciation, in that wonder, in that capacity to find meaning in deep time, you justify every cosmic collision, honor every extinction, and celebrate the profound creativity that turns every ending into a beginning more beautiful than what came before. The memory fades now, but its essence remains, woven into your dreams, embedded in your atoms, expressed through your consciousness, and available whenever you choose to remember that you are both child and parent of the cosmos, both inheritor and creator of worlds beyond imagination. The day the sky fell has become the night when new dreams take flight. Rest well, child of the impact, descendant of survivors, inheritor of transformed worlds, consciousness through which the universe contemplates its own infinite creativity.